Hello guys, today we're going to be talking about atoms. Now some of our notes might be repeating some of the information that you learned during your atomic theory web quest. We're going over some of the important discoveries, important people, what exactly atoms are, what their structure is. So everything we are going over in these notes is important for you to write down. Please make sure you're writing the information down. You will have a quiz on this material on Friday. As long as you're writing all your notes down, you should be able to get an easy 100% on that. So make sure you're taking your notes completely. All right. So our title up at the top of the page is going to be atoms. Below that, we need to be writing our essential question: how do atoms make up the world around us? Below the essential question, you should be dividing up your page into two columns. You know the drill with the Cornell notes. The smaller column is for you to fill in any key points, questions, important words, that sort of stuff. Larger column is for your notes, and at the very end, we are doing a summary. So let's get started. First of all, what is an atom? Well, atoms are the basic particles that make up all matter. You can't really break matter down into any smaller whole piece. Now, atoms are very difficult to study. The reason why is because they are so small. They are actually so small that a single speck of dust can have 10 million atoms in it. So they're very tiny. So they're really difficult to study. And for that reason, scientists use models to study them. And models are a visual representation of things that are difficult to study or difficult to see easily. Now, over time, the atomic theory and the models that we have used for atoms have changed. And that's because scientists have made new discoveries over the years. As technology has improved, so has our ability to study. So that is why the atomic theory and the models have changed. That would be an important piece of information. You will see that on a test. Seriously. Know why the theories changed. So the very first atomic theory was written by a guy by the name of John Dalton in 1808. So this was the first atomic theory. This is not the current modern version, but a lot of the information that John Dalton said is still valid today. And his atomic theory had 4 parts. It said that matter is made of indestructible atoms. All atoms of the same element are identical. Compounds are formed by a combination of atoms. And chemical reactions are a rearrangement of atoms. For the most part, a lot of this is still valid. It is possible for atoms to be broken so they're not entirely indestructible, but it is so difficult to break them that they might as well be indestructible. So that first part is still not 100% valid, but really close. As far as all atoms of the same element being identical, that is pretty much true as well. There are a few exceptions, but we'll talk about that in a few minutes. Compounds are formed by a combination of atoms is still very true. Today, we've never found any evidence to contradict that, and so everything in this universe, not just on Earth, in the whole universe, is made up of different combinations of atoms. And chemical reactions, this is still another valid one. We know now that a chemical reaction is nothing more than just moving atoms around. And we'll talk more about chemical reactions in particular when we get back from winter break. But for the most part, this is still a very valid version of the atomic theory. It's never really been totally disproven or anything like that. So a few important people who contributed to atomic theory. Yes, write these names down. Probably a good idea to write down the dates or the years, because I have a feeling that might be on your quiz on Friday. So important people. J.J. Thomson in 1897 discovered electrons. And if you notice, that's about 90 years after the original atomic theory was written by John Dalton. So it was almost 100 years later, almost, that the next major discovery was really made. So it takes a long time to study atoms. But anyways, again, J.J. Thomson discovered electrons. A few years later, Ernest Rutherford in 1911, through his experiments, he found evidence that suggested that the atom was mostly empty space, with a positive charge at the very center of it, and that would be the nucleus, which we'll talk more about in a little bit. Just a couple years later, Niels Bohr, 1913, he suggested that electrons orbit around the nucleus. And then a little bit later, around 20 years later, James Chadwick in 1932 discovered the neutron. So let's talk a little bit about the structure of atoms, since we just talked about some of the major discoveries about the structure. The atom is kind of like a ball. It's a sphere. At the very center of that ball, you have the nucleus. And the nucleus is made up of two things. There's protons and neutrons. Now, these are both tiny particles. We call them subatomic particles because they are part of the atom, but they're smaller than the atom. They're part of it, not something separate. Now, protons have a positive charge, and neutrons have no charge. So that means that the nucleus has a positive charge. The nucleus makes up most of the atom's mass. For the most part, outside of the nucleus, there is a lot of empty space, and you have the electrons which move around the nucleus. Electrons are very small. They don't have much of an impact on the atom's mass, and they are negatively charged. Now, a neutral atom will have the same number of electrons as protons. Most atoms are neutral to start off with. So basically what happens is you have a number of electrons that say they have 7 electrons. And each of those has a negative charge. So the charge, if we're just looking at electrons, is -7. Well, when you have the protons, if you have the same number, you have a charge of +7. So -7, +7, if you put them together, you try adding them together, you're going to get 0. So they balance out. So in a neutral atom, the number of protons is equal to the number of electrons, and their charges balance. So that makes the whole atom neutral. Now, are all atoms the same? To an extent. All atoms of a particular element have the same number of protons. The number of protons is what makes that element what it is. That's how we identify all of the different elements, by the number of protons. Now, there's something called an isotope. And what an isotope is it's basically another version of that element. So isotopes are atoms with the same number of protons, but a different number of neutrons. Now, in a regular atom, it is usually the same number. but there are different versions of it that don't have that same number, and in the picture off to the side you can see there's a few different isotopes of carbon. Many elements have isotopes. I don't believe all of them do, or at least not naturally occurring, but many of them do. Also, atoms can gain or lose electrons. This is what happens during chemical bonds, which we'll talk more about after Thanksgiving break. But just know for now that it is possible to gain or lose electrons. This will give the atom a positive charge because now there are fewer electrons, which are negatively charged. There are fewer negative charged particles than there are positive now. So electrons and protons, when they don't balance out, we end up with a charge. Now the periodic table. We'll be taking more notes about the periodic table later this week. We'll be working with it more. But we can learn a lot about atoms of a particular element just by looking at that box on the periodic table. So those boxes on the periodic table tell us a few things about the element. The first thing that's on there is called a chemical symbol. It's basically just a couple letters representing that element. Think of it kind of like initials. But there are two numbers that are important to tell us about the atoms. We have the atomic number and the atomic mass. Now the atomic number is the number of protons. It's also equal to the number of electrons if that particular atom is neutral. So we can find the number of protons and the number of electrons just by looking at the atomic number. Atomic mass is the number of protons plus the number of neutrons added together. And you'll notice a lot of times that very often the atomic mass has a decimal. And the reason why is because of the different isotopes. Since the atomic mass is protons plus neutrons, isotopes have a different number of neutrons. So when you add the protons and neutrons together, it's going to be a different number if there's a different number of neutrons. So on most periodic tables, it'll show an average of the different isotopes. So if you see a decimal place, that's what it means. So from the atomic mass, we can find out how many neutrons there are. We already know the number of protons from the atomic number. So if we want to find the number of neutrons, all we have to do is subtract the atomic number from the atomic mass, and then we have the number of neutrons. And that is it. Yes, you do have to do your summary, so please make sure you do it. Don't ask me if you have to do it. You know the answer to that. And that's it.